Good morning, everybody. Today we will be moving on to the next module. It is of electrodynamics, which is coming from the book Griffith, David J. Griffith. So you have to study 7, 8, and 9 chapters of this book, but not full part of these chapters. Small sections. So first we have Maxwell's equations. You might have heard about Maxwell's equation in your plus 2 classes. They are actually four equations which are in which three of them are Gauss's law, Faraday's law, and Ampere's law. They are all separately studied already. I will just rewind it, the equations only. So these equations, Maxwell's equations, you can write either in differential form or in integral form. So normally we use this differential form. That is what written here in this note. So you can see Maxwell's equations. We have two divergence equation and two curl equations for the electric and magnetic fields. So that is what first one, Gauss's law, which is del dot E, divergence of electric field. What is it? It is equal to rho by epsilon 0. What is rho there? Rho is the charge density. Epsilon 0 is the permittivity of free space. So we know this equation. You can write it in integral form also. E dot ds is equal to that is also you can write. But now let us E dot ds integration. Integral E dot ds is equal to q. That is what you can write. But we need now only the differential equations. So this is divergence of electric field. Now what is divergence of magnetic field? That is the second Maxwell's equation, which is equal to 0. Del dot B is equal to 0. Divergence of magnetic field is equal to 0. This is not named with a law or something. There is no name for this equation. This just says that no magnetic monopole can occur. So like electric charge plus q and minus q can separately occur. So, here this north pole or south pole cannot occur separately. North pole along with south pole also will be there. That is what del dot B is equal to 0 means. That equation means. Third equation is del cross E, which is the curl of electric field. The curl of electric field is d by dt minus d by dt of B, which is magnetic field B. So this is called Faraday's law. Now curl of magnetic field B is equal to mu 0 into J, where J is the current density. Remember, rho was the charge density, J is the current density. So magnetic field will be developed only when charge is moving. You know that. When charge is moving, that means current is developed. So when current is there, then around that wire through which the current is passing, there will be magnetic field. That is how magnetic field is developed. So the curl of magnetic field means it is mu 0 times J, which is equal to mu 0 times J. Okay, so you can just read this in the previous chapters of Griffith. Now we are studying 7, 8 and 9th chapter. So we have started Maxwell's equation already, and this last equation is Ampere's law. Remember that. So you have to remember these four equations thoroughly. Now let us see the last del dot del cross E. Let us see divergence of the curl equation, divergence of the third equation. Del cross E, third equation we take the divergence of it. That means del dot del cross E. That means del dot minus dou B by dou T, isn't it? So we can write it as minus dou by dou T of del dot B. We know that the divergence of a curl is already 0. It should be 0, isn't it? So this equation when you do the divergence of the curl equation, third one, del cross E, then you get minus dou by dou t of del dot B, isn't it? So del dot B is already 0 from second equation. So this equation is correct. Divergence of a curl is 0. We can say that the equation is correct. The third equation is correct. The LHS is 0 by the rule of divergence, and that is the divergence of a curl is 0. RHS is also 0, that is because del dot B is equal to 0. Now let us take the divergence of the fourth equation, del dot del cross B. What happens there? It should be right hand side will be mu 0 into del dot J. So right hand, we know that left hand side is already 0 because divergence of a curl is already, it is always 0. That is the rule. But right hand side, see, we cannot say that always del dot J is 0. Right hand side in general is not 0, but for steady currents del dot J is 0. But we don't know, but for varying currents whether it is 0 or not. So del dot J is not equal to 0 for magnetodynamics, that is for varying currents. Now let us see. So that means the fourth equation is not necessarily correct. It may not be correct sometimes. So we have to correct that equation. Fourth equation we have to correct. That is how Maxwell. So the fourth equation is not exactly correct equation. Ampere's law is not exactly correct equation. Maxwell has done a correction to that equation, so we have to modify the fourth equation. So we cannot just write that del cross B is equal to mu 0 J. That should be corrected. So exact Maxwell's four equations you have to write after doing the fourth equation's correction. Okay, so let us do the correction. Maxwell has done the correction of this Ampere's law. First he checked what is del dot J. By continuity equation we know that del dot J is minus rho by dou T. So we know that the rate of change of charges moving out of the system is same as the rate of change, the charge coming inside. So it should be del dot J. So del dot J should be equal to minus dou rho by dou T. So that is continuity equation. So he had taken that equation and substituted for rho there. Rho is from first Maxwell's equation. By Gauss's law, rho is what? Rho is equal to epsilon 0 into del dot T, isn't it? So that is what substituted there, minus dou by dou T of del dot T into epsilon 0, which is equal to minus del dot. You can take del dot out. So minus del dot dou by dou T of epsilon 0 E. Epsilon 0 is constant. So epsilon 0 into dou by dou T of E. We have used here Gauss's law. Now move this right hand side to the left hand side. Left hand side is del dot J. So del dot J is equal to minus del dot epsilon 0 dou E by dou T. So both terms are having del dot divergence. So we can add the terms inside the divergence, the terms which is going to take the divergence, to which the divergence is taken. So del dot J plus epsilon 0 dou E by dou T you can take. So right hand side is moved to left hand side, and del divergence is taken together for the terms. So that is how del dot J plus epsilon 0 dou E by dou T comes, which is equal to 0. So right hand side becomes now 0. Now this equation, see this equation. So now the equation is 0 if we change J to J plus epsilon 0 dou E by dou T. So instead of writing mu 0 J, we have to write J plus mu 0 into instead of J you have to replace J with J plus epsilon 0 dou E by dou T. So the correction made by Maxwell is that it is like this. Now fourth equation becomes del cross B is equal to mu 0 J. J ki pagaram we are replacing, instead of J we are replacing J with J plus epsilon 0 dou E by dou T. Then the equation is correct. So the right hand side is now correct when you take the divergence of the right hand side, isn't it? Because he said already here that del dot J plus epsilon 0 dou E by dou T is 0. So we know that is 0. So divergence, if you take right hand side, then you will get 0. So this is now corrected. So always remember this equation. This is the fourth Maxwell's equation. This is the corrected Maxwell's equation. So if we consider, now let us consider magnetostatics. That means no movement, dynamics is not there, no movement is there, charge is not moving there. Then what happens? Change in electric field will be 0. That is dou E by dou T becomes 0. So it reduces the norm, it reduces into normal Ampere's law. So the dou E by dou T 0 means it is right hand side mu 0 J only. Mu 0 J only means del cross B is equal to mu 0 J. Okay. Now we define JD. JD, epsilon 0 dou E by dou T is equal to JD. What is JD? Their displacement current. So we call this as a term with we call this with a term that is displacement current. Okay. So now we know the all the four Maxwell's equation. First one is Gauss's law. Second one has no name, but it means no monopole can exist. No magnetic monopole can exist. That is second law says. Third law is del cross E, which is minus dou B by dou T, and fourth law is del cross B, which is equal to mu 0 into J plus epsilon 0 dou E by dou T, after correcting with the after correction by Maxwell. Okay, now let us move on to Maxwell's equation in matter. So what happens when we consider matter? We know already that in static case an electric polarization produces a bound charge density. Rho B. Rho B means the bound charge density. So if you have a system where it is static, that is no charges are moving, but a small vibration can be there. So because of that, electric polarization occurs. Some side will be more positive and the other side will be more negative. So that is how electric polarization happens. So due to this electric polarization, there can be bound charge density. So the bound charge density, you can write it with the minus del dot P with the electric polarization. So and also the bound charge current. Bound current due to the magnetic polarization. So due to the electric polarization we have bound charge density, and due to magnetic polarization we have bound current density, JB. JB we can write as del cross M. So remember these two equations. So divergence of electric polarization gives charge bound charge density, and curl of magnetic polarization gives current density, bound current density, JB. And now in the non-static case, any change in the electric polarization involves a flow of bound charge. So and we call it as JP. So when you have a non-static case considered, that means if the charges are started to moving, so these bound charges will be moving, it will be flowing, isn't it? So due to this flow, there will be a current developed, isn't it? So due to this current, there will be a current density. So that current density is JP. JP is equal to dou P by dou T, because electric polarization is varying with the time there. So JP we can write it as dou P by dou T, the polarization current. We call JP as polarization current. Now Del dot Jp, how will you take del dot Jp? Divergence of Jp you have taken for equation 8. So right hand side also take the divergence. It will be dou by dou t of del dot P, which is rho B, isn't it? So dou by dou t of rho B you will get del dot Jp, which is equation 9. Now we know this is continuity equation, isn't it? And it is satisfied. The total charge density is having now two parts. So we have now two parts for the total charge density, rho B and rho F. What is rho F? Due to the flow of charge. Charge density, the flowing charge density is rho F. So we have rho F and rho B. If the charges are not moving, the charge density is rho B. If they are moving, the charge density is rho F. So we have to add these to get the total charge density. So rho F plus rho B is equal to rho F minus del dot P, which is coming from equation 6. Okay, so del dot T we can write it as instead of rho we can write rho F plus rho B, which divided by epsilon 0. And substituting rho F minus del dot P by epsilon 0. Take the divergence together to the left hand side. You will get del dot E minus P by epsilon 0 is equal to rho F by epsilon 0. Now multiplying throughout with epsilon 0, you will get del dot epsilon 0 E minus P is equal to rho F, isn't it? And epsilon 0 E minus P we call it as D. We substitute as D. So del dot D is rho F. So the flowing charge current density is del dot D, where D is epsilon 0 E minus P, where P is electric polarization. So now what is the name of D there? D is electric displacement vector. I didn't write it there, but you just remember what is D, the name of the D vector. D instead of E it is D now. Electric field ne pagaram ippam D aanu. D ide peru ennaanu? Electric displacement vector. It is called electric displacement vector. Del dot D is equal to rho F. What is rho F? Rho F is the flowing charge density. It is not the full charge density rho, but it is rho F only. Rho F is the flowing charge density. Okay. Now boundary conditions I will teach you in the next class.